I am Dr. SUPRIYA, working as an Associate Professor in the Department of Chemistry, Satyabama Institute of Science and Technology, deemed to be University. Now I am going to explain to you about the estimation of glycine by Sorensen's method. As you know, glycine is an amino acid which consists of an amino group and an acid group. Glycine exists in the form of zwitter ion. Therefore, the COOH group present in the glycine is not free for carrying out the titration with a base, and in that way we cannot estimate directly by titrating it against sodium hydroxide. The amino acid glycine has this formula NH2CH2COOH. In any amino acid like glycine, the NH2 and COOH groups are not free as they exist in the form of zwitter ion like NH3 plus CH2 COO minus. Therefore, in this case COOH group is not free for carrying out any acid base titration with a base as in the case of normal acid base titration. Therefore, we need to adopt a different method so that we can estimate the amount of glycine present in any given solution. The method we are adopting here is the use of formaldehyde to block the amino group so that the glycine does not exist in the zwitter ion form, and therefore the COOH group will be available for carrying out the normal acid base titration with a base. In the experiment estimation of glycine by Sorensen's method, there are two titrations involved, and the solutions we require for carrying out the titrations are oxalic acid, sodium hydroxide, formaldehyde, glycine solution and phenolphthalein indicator. We will move on to the first titration. The name of the titration is standardization of sodium hydroxide solution. So, first titration is the determination of strength of sodium hydroxide solution. We are going to pipette out 20 ml of oxalic acid, and in the burette we are going to take the given sodium hydroxide solution. The titration is carried out between the two using phenolphthalein as the indicator. At the end of the titration, there will be a slight appearance of pink color, and that is going to be the end point of the titration. The titration is repeated to get the concordant value. Now I am going to proceed to show how the two titrations can be carried out. The first titration is the standardization of sodium hydroxide solution, followed by the estimation of glycine. We are going to get the concordant value for both the titrations. I am going to explain to you how the two titrations can be carried out. Titration 1 is the standardization of sodium hydroxide solution. For that, sodium hydroxide solution should be taken in the burette, and 20 ml of standard oxalic acid solution should be taken in the conical flask. To the oxalic acid solution, 2 drops of phenolphthalein indicator should be added, and this solution has to be titrated against sodium hydroxide taken in the burette. The end point of the titration is the appearance of pale pink color. The appearance of pink coloration is the end point of the titration. The titration has to be repeated taking oxalic acid and sodium hydroxide in the burette. Let us say the concordant value is 30 ml. So, that has to be entered in the table. Titration 2 is the estimation of glycine. The glycine solution given in a small bottle has to be first made up in a standard flask. The making up of solution is the glycine solution as such should be transferred completely into the standard flask. After completely transferring the glycine solution, add small volume of distilled water to the bottle and transfer the rinsing also into the standard flask. This has to be repeated 3 or 4 times in order to completely transfer all the glycine solution into the standard flask. After the complete transfer of glycine solution into the standard flask. The volume, the required volume, that is 100 ml volume in the standard flask should be made up using distilled water. After the addition of distilled water into the standard flask, the lid should be placed and the standard flask should be shaken for uniform concentration. From the made up glycine solution, 20 ml should be pipetted out into the conical flask. So, the 20 ml volume of glycine solution from the standard flask is now going to be pipetted into the conical flask. After transferring the required volume to this, a 5 ml solution of formaldehyde should be added and 2 or 3 drops of phenolphthalein is added. Now, the conical flask solution is ready for the titration. The glycine solution is titrated against the standardized sodium hydroxide taken in the burette. Once again, appearance of pale pink color is the end point of this titration. The titration should be repeated in order to get the concordant values. Let us say the volume required, sodium hydroxide volume required for this titration is 7 ml. Now, I am going to show you how the tabular column has to be filled with the readings. From the first titration, that is the standardization of sodium hydroxide solution, the concordant value, that is the end point we obtained as a result of titration was 30 ml. So, the final burette reading will be 30 ml. In burette we have taken sodium hydroxide solution, therefore 30 ml of sodium hydroxide was consumed for the titration and we repeated the titration to get the concordant value and it is the same 30 ml, therefore the value is 30. For the second titration, in the estimation of glycine, the end point volume of sodium hydroxide consumed for the titration was 7 ml and since it is the concordant value, we are going to use 7 ml for calculating the amount of glycine present in the solution. The steps involved in the determination of amount of glycine is: first, the normality of sodium hydroxide is determined from the equation V1N1 is equal to V2N2. V1 is the volume of oxalic acid, which is 20 ml, what we have pipetted out using a pipette. N1 is the normality of oxalic acid, which is already known to us. V2 is the volume of sodium hydroxide that is required for the first titration, and N2 we are going to calculate. So, from the first titration, sodium hydroxide normality is determined. Now, this normality is used for the second titration, which is the estimation of glycine. The same formula is used, V1N1 is equal to V2N2. In this case, for the second titration, V1 will be the volume of sodium hydroxide consumed, N1 is the normality of sodium hydroxide obtained from the first titration, V2 is the volume of glycine, which is 20 ml, and from that we are obtaining the normality of glycine, that is N2. So, after getting the normality of glycine from the second titration, it is multiplied by the equivalent weight of glycine, which is 75, to get the amount of glycine present in 100 ml of the solution. The volume we made up in a standard flask. The value obtained here should be divided by 10, and that is going to be the result of the experiment, and it is the amount of glycine present in the given solution. Thank you.